Okay, so the next question is running sum of 1D array. So you will be given an array and you have to define a running sum of the array. You have to return the running sum of the arrays. Here you will see that a running sum of the array is basically at that particular index of the output array. You will basically have the sum of all the numbers from I till that particular index. Okay. Now over here, what you will see is, first of all, if you're new to LeetCode as a platform, this is the place you actually have to write your code, right? And where you will basically be running it to see if it passes a few normal cases, and then you can submit it to see if it passes all the test cases or not. Okay. Second thing is, one important observation to make in this question is, if the input array is of size 4, the output array is also a size 4. Right? If the input array is of size 5, you know that the running sum array would also be of size 5. In this case, you can already tell by looking at the input what is the size of the output. So there is no need at all to be making a array list over here in order to be able to get your output. Okay. Now heading back to the question and kind of figuring out a good way to solve this is, let's say the input values are 1, 2, 3, 4, 1, 2, 3 and 4. Okay, and over here you have to create this running sum array. One simple way to do this and a brute force way to do this is, for this part, what do you do is you add all the elements from here to here, which is 1. For this part, what do you do is you run a loop from here till here and basically keep the sum 3, right? For basically keeping the output over here, take a loop starting from here up till here and adding all the elements and putting the output over here. Then over here, run another loop starting from here up till here and then storing the output 10. Okay, that is one way. This will lead to a n square kind of like an approach where you will be using 2 loops over here to find the output. A better way to do this is basic maths that you can apply over here. Let's say, let me take slightly bigger array for a better visualization. Let's say what will happen is, this particular index is, let's say, called the x index, right? Now, what you simply have to do is, or what this position represents is, the sum of all the elements from the 0 to x index, correct? And this position represents the sum of all the elements from 0 to x plus 1 index, right? Now, don't you think this could actually be broken down into the sum of all the elements from 0 to x plus the element x plus 1, right? Is this nothing? The sum of all the elements from 0 to x plus 1th index is nothing but the sum of all the elements from 0 to x index plus x plus 1 to it, which is the current element which is newly added, right? And that is the approach that you have to apply as well, right? For example, over here the sum was what? 10, right? Now you have to do the summation of this. Can I not just do the sum of all the elements from 0 to x, which is 10, plus the current element 5, which will basically give me 50, right? I don't have to go over each and every particular window or each and every particular element, right, to be able to find the sum again. So every time what I will be now doing is to find the output. The first element will go as it is, right, over here, which will be 1 itself. Okay, post that, what would be happening is, for basically finding the answer for this, I will be taking 1, I will adding 2 to it, and the final output is 3. For this position, the output will be, I will taking the element 3, I will be adding 3 to it, and the final answer is 6. For this position, I will be taking 6, I will be adding 4 to it, and the final output is 10. For this output, I will be taking 10, I will be taking 5, I will be adding both of it and dumping the answer over here, which is 15. And in this case, you actually do not have to apply 2 different loops over here in order to be able to find your output. Okay, and this is how you can simply find the answer, or you could simply find the running sum array for the given input. So over here, if I will go, I will first make a resultant array, new int nums.length. Okay. Like I said, for the very first position, you don't have to do anything because before that there are no elements. So directly in the resultant array, copy the element in the original array and then just start from the very first index. Right? So it's like if I have to find, if this is my ith index, if I have to find the answer for this position, I will take the prefix sum, or this is called prefix sum. If I will take the value of the I minus 1th index from resultant array, add the original array current value to it and store the output. So this is result. At the result ith index, I will basically take the value in the result array only at the I minus 1th index, because that will store the sum from 0 to x plus the current value of the array will be taken. Okay. And in the end, I will simply just return the result. Let's see if it basically runs on the normal cases. Yes, it does. And now if you will submit it, it will tell you if it works on all the cases or not. Okay. And since it does work on all the cases, your output is absolutely correct. Right. And this approach is typically called as the prefix sum approach. Right. Prefix is where you are basically trying to add a particular number up till a particular point and then storing it over here. Right. And this forms the question running sum of 1D array.